most of the students got approval of the selection of your NoSQL database, please do research. Okay, so some of the students just copy and paste from the Wikipedia, but it may not have to proceed the third and the fourth page later, because eventually you are going to implement and show the demonstration of using NoSQL database based on your modeling and the application. So please first start from the link that you selected the NoSQL database, and most of them provide the documentation as well as some blog and the forum white paper. Okay, if you can find some the published paper regarding to your selected database, that's much better. Okay, please research and then include the whole the reference in the as a citation. Okay, not only just a link but also any other. So if you just copy and paste from the without proper citation, it will be the it will cost something high. The plagiarism the score through the Turnitin.com. So please be careful. Okay. So then I think the after the due of the phase 2, we will have the presentation time. It will be short presentation for each student, like 3 to 4 minutes. But we have the 20 students this semester. So it may take even longer than an hour. So I will give the 3 to 4 minutes presentation today after the second phase. So then today we are going to talk about a very interesting topic, which is a cat theorem, which is a fundamental of understanding the NoSQL database. Actually, it's not only for the NoSQL database, from the relational database model and the NoSQL database, and the future, the new SQL database, to understand such a history, the timeline of the database, the system, this cat theorem will be very, very helpful. Okay? So we will talk about this one today, and working on the phase 2 is the research on your selected database. If you do not, if you cannot see your name and the selected database from the first page of Canvas, you need to select, then email me as soon as possible. And today we are going to have the third exercise lab that will cover the rest of the MapReduce programming. So please be ready for your virtual machine. It may be depending on our discussion, but hopefully I will give the 30 to 40 minutes for your exercise lab at the end of today's class. Okay, so any questions regarding to before we start? I have read one interesting article while I'm preparing new material for the new SQL database, because so last couple of years I taught this NoSQL database. That's after the relational conventional database. Then I realized that nowadays it's another trend. Actually, it's not another trend, but new SQL database like the Google Spanner, and some of you already selected a new SQL database. So to introduce such a new trend in my class, so NoSQL database, so I read an article, several articles, and then I have seen the very interesting article to explain about the database system. I know that some of you guys are very interested in the database system. So do I. So probably I mentioned about the background before I start the studying. So actually my major was not the computer science. So I started my undergraduate was the mathematics education. So I tried to be a math teacher. From time to time I'm teaching my son math, but he doesn't like it. So however, anyway, so a lot of things happened during my college and for my military service. So finally I got a job from a bank. Then I was hired as the database administrator. Okay. Then the only reason probably I mentioned, so due to my major, the supervisor, he believed that I can do better than others to understand the relational database, because I had a background in the mathematics. So then I probably spent a couple of years to know about not only relational database, but the administrator job for Unix network admin. So I was hired with two other my colleagues. So one is three other. One is for the Unix administrator at the time, and another one is network administrator. Then third one was the middleware, the administrator. Like right now we have the application server, like the web application server, where there was specific the software which is called the middleware. Like if you think about the three-tier architecture, we have a server and the client, and in between is a transaction monitor. So sometimes it's called the TP monitor, where the Tuxedo and nowadays application server is in charge of such a job. So, but I was the database administrator, but I should know the Unix network and such a TP monitor, and I didn't have any background in the programming, so to deal with the developer, I should learn the programming also. So I spent couple of years to learn such all the stuff of the. Later I realized that is the kind of taking all the classes around the computer science, and I realized that because that is for the practical part, not theoretical part. It's not like the class. Okay, so I felt a lack of such a background, fundamental of the computer science, specifically database part. I know how to create a table, how to use Oracle, but I do not know much about the behind the theory of the database. What if I am able to develop the new database system? Or is it possible to develop the IDBMS and so on, something like that? So I decide to study abroad. And I just, at that time, I didn't know much about any research. Even I do not know what is exactly PhD is doing, and what is the GA or TA, RA are doing, and the postdoctor, I do not know. So then I came by several the professor who major in the database in my old university. One of them is the Dr. Emersary, the author of the database design textbook. He was well known for the conceptual design, conceptual modeling, like ER modeling and so on, long time ago from Stanford University. Then he said, there's nothing you can do in the relational database. And because I asked, is there any research opportunity related to the relational database? Because I had, at the time, the 7 years experience on the database. So I think that I can do better than other students for the related to the relational database. But he said, there's not much opportunity in the relational database. So why don't you find the topic in computer science? But the professor suggests, if you are interested in the database, why don't you think about the different data type? Unlike the text or the alphanumeric data, the multimedia data, like the image, video, then specifically at that time when I started my PhD in 2002, not many the researchers who are doing the video database, something like that. So also even at the time, eventually my supervisor, when I contact him, he suggested, why don't you apply the data mining technique, like the techniques where the sulfur-to-vector machine, neural at the time, so to the video data. Right now it's very popular with the power of the deep learning, but it was not that simple. Even the computing power was not good enough to process the video data. But anyway, so I started my research on the multimedia database and the multimedia processing. Then, but still, even though I'm teaching the database and the data related course, was not very clear sometimes what is the difference between data and information, and what is really data itself. I can explain what I can teach in my advanced database design class. The data is the data structure to keep the information it's more structured data or information, it's meaningful information, then we can group to process data. But last week, I have seen the article that mentioned about we can explain the database system in one equation. And we have data, or sometimes we can call the database. It's a source. Then we have function. Then output of input is the data. Then using the function, whatever the function, we can get the query output. So this is the data and the database system. So I agree. I totally agree. I like this the approach. So function means it can be the program. It can be DBMS. It can be search engine. It's whatever. Okay. Then that deal with the data. So sometimes it's a collection of the data. So from that, our goal of this function, this system is to get the result. It's not only for the database system. Almost all the subject in computer science, why do we use computer? So get the benefit of fast processing. So fast. Then eventually we should have the output. So the function can be the main target to handle. We need to learn the programming code. And to deal with the data, finally we get the output. Like if you are interested in the machine learning, it can be algorithm. So then, the problem, what is this guy? The data. Okay? So data. So we discussed a lot in the advanced database design, but we can compare with the information. The data, once we put something information in our computer system, data is a live thing. In other words, it can be dynamic. Or it can be whatever. Comparing to the information, which is static, okay? On the other hand, the data is dynamic. It's a live thing. So for example, if you remind your data structure class, so long time, CS 1 or 2, who had this undergraduate level. Some of you guys took such a data structure class, freshman, or at least a sophomore. If you major in the computer science at the time, so you learned about the several data structure. So linked list, or the step, and queue, tree, and graph, and so on, right? Do you remember that? Then, for each the structure, we are going to evaluate. So evaluation means, so we'd like to judge which one is faster data structure. Using what? One is PO notation. Okay? Which one is dominant? So from the calculation of the computation, number of computation, then take the dominant one, highest degree. Okay? Another, the evaluation metric is space. The memory space, how much we use. So these two are the main, the metric, to evaluate this one. For each one. For what? Operation. So that operation is insert, update, delete, and the select. Better way. Anyway, so insert. So update sometimes delete and insert, but we consider full operation. Okay. In database, if you go back to your advanced database or database design course, if you already took in your undergraduate, so we have the very similar operation in any kind of database. Doesn't matter whether you have used a relational database, any type of database is a CIUD operation. C means create. R means retrieve, and U means update and delete. So we had the CRU. Actually, it's almost the same as this one. Database is from this the data structure operation. So we have the CRUD. So in the CRUD, especially the update and delete. So if we update and delete the data, it's another state, another version. Right? So for example, if A is 1, the K attribute, the A is 1. Then if I update 2, this time, along the time, A exists, but it's a change. So like you are alive, but the year later may not growing up, but the change, right? So keep changing because you are alive. If you are steady, which means if you already die, right? Then it's not much changes. So because data is along the time, so it may be changed. It can be changed because of this operation. So this is called the version, or it's the database state. So data is kind of lively comparing to the information. However, because of this one, it's really complex. Okay? So if data is keep changing or updated, then we need to manage. So when I select the data, when I retrieve the data, I expect the one. The one, it takes a time definitely to retrieve or to search the data. It will take a time. During that time, it's changed into 2. So is it correct or not? So to deal with such a live thing, definitely it's more complex and harder and takes a longer time, and there might be limitation. Because of that, we need to consider something additional feature, like in the relational database, a lot of algorithms we are going to discuss in the advanced database design. Next class, we will see the more details review of the such a database system in terms of data structure and transaction model and so on. But if you remind in advance, so like the transaction management in the concurrency control, such as it's overhead, okay? Because of this kind of characteristic. So, what about when we have a really large amount of data, big data? It's a really problem, right? So we need to address that problem. Then finally, we consider NoSQL database. So NoSQL database is not really opposite of the relational database, but try to address such a problem. Then how to address? To understand such a point, so we are going to see the fundamental of that. That is called the cat theorem. So if you remind the idea, motivation of the NoSQL database based on the big data system, what we discussed before, what did we discuss? Instead of one centralized system, we can put another one, another one, another one. It's the distributed system. Divide and conquer. So we can definitely, one system is limited, even though Amdahl's law, the Moore's law suggests every other year, 1.5 years, the CPU speed is double. However, they cannot catch the increase of the data size. So one system cannot address the problem of the big data. So we can put another system, another system, another system. Like as you learned in the last 2 weeks, it's a Hadoop. It's one of the solution. Okay. So however, so when we consider such a number of nodes, in other words, distributed system, can we keep the same the character property of the centralized system or not? If not, how to address? What is the difference and how to address? So that is based on the cap theorem. So today we are going to take a look at this cap theorem. So until the last semester, I just introduced what is a cap and what is the type of the NoSQL database based on the cap. But recently there are a lot of the try. Some of them are successful, the others are not, but try to address even the limitation of the NoSQL database, which is called NewSQL. So I will introduce how to try to attack the cap theorem. Okay, to do that first, we are going to take a look at what is a cap. To understand the cap theorem, so first we need to understand this one. This is the centralized server. So focusing on that, why don't we narrow down the database server? It's a centralized database. It's the most popular. Most of the relational database is based on this one, the centralized. Somebody can argue. I have seen the Oracle database like this one, and can support. Mostly they are supporting high availability, which means they are the same server. So in case one of them fails, it's a takeover. Okay? So one is kind of backup server. It's not the really distributed server. There was such a distributed system, but before to understand the distributed system, so this is the CPU, memory, and the storage. Each one has this one. This kind of architecture is called shared nothing. They do not share anything, only the connected. Okay? It's a shared nothing distributed system architecture. Another thing is you can share the storage data. This is a doable. Very, very popularly used. Using what? The SAN architecture. SAN stands for storage area network. We consider storage as a node, like a computer. Then the problem of implementing such a storage area network is network latency. Because even though you are using the gigabit Ethernet and very fast is the network, but that's much, much slower than what? The bus. Okay? So we cannot catch up the bus speed, which means accessing the data from the local storage is much different from accessing the remote storage due to the network latency. However, if we are using fiber channel is much, much faster, 30 to 60 times faster than the gigabit Ethernet. So we may not realize such a network latency. It has some distance limitation, but still several miles away, so you can connect this one through the fiber channel. Then from each node, we may not realize whether this storage is in the local or remote. Even nowadays, such a storage box, for example, EMC is one of the IT company. So one of my colleagues who was hired with me as a Unix administrator, he quit in advance to me. He quit the job and moved to the EMC. So his job is just to sit on his office, and if something happens in Europe, then ready to fly away to the Europe. And it's technical, the support technical, the service engineer, something like this. So always a standby. So it looks like good, but a couple of years later, it's really for his family. Anyway, so EMC, for example, EMC is such a storage. You can dynamically change or locate the storage to the server. Daytime online server takes more, but the daytime, the batch job takes this. So this is doable. But then one more, the architecture is a shared memory. Because the main problem of to implementing distributed system is the CPU can access the data only memory. Okay? So which means if you have the CPU scheduling, so any update data like the after context switch, the PCB implement, process control block. PCB information stored at where? Memory. This one. Same thing this, same thing this. If you update even the programming, if you run the program, that program any change data in the local memory. So this one cannot access this. This one cannot access this. So it was there was architecture to connect such a CPU, memory, and connect this memory using memory channel. It's a memory bus. It's a very, very expensive. The hardware I never used. I heard that, and it's exponentially difficult, complex to set up and run the program. Even though we have the memory channel. Okay, so shared memory is possible, but it's practically not feasible. Especially when you have like 100 nodes, they need to connect all each other. So the synchronization problem always happen. So it's very, very difficult. So most of the distributed system either shared nothing or shared the disk. Even though you share the disk, this data, mostly they do not share. If you share the real data, there might be synchronization issues. So then, to use such a distributed system long time before, we can have the create the employee table 1, employee table 2, employee table 3. Okay? Using what? The horizontal, the partition. So this is for New York is here. This is for Dallas, for here. And this one is for the LA, and this one, sharding. So using the sharding technique, divide, partition. That's the partition table. Then run the select. For example, from is employee, but automatically this one inside during the query optimization, select something from EMP1 partition. Then another query is in the EMP2 partition, and so on. It query optimizer can distribute the such a select, just like the parallel program. Then looks good, but very limited. Like the, for example, join. If you want to join, that table is everywhere. Okay, so it's all combination. So huge network overhead. Specifically, if the server is located in the different data center, it will take a time and a really long time and much more. I have used such a Informix XPS support such a database, relational database system. We have used a couple of years, then the give up. Very expensive and very high maintenance fee, and even output is not so good. So theoretically it's possible, it has not been used. So this is the distributed system and so on. So we can understand. But we have our solution to when we have the really big data, this one cannot fit the feature to the big data. So our solution anyway to use the distributed system. Sometimes it's called a cluster. So by keeping all the functionality of the relational database, we cannot get the full benefit of such a linearly scalable performance. Okay, so we need to change. So to do that, we are going to consider when we have only one centralized server, we are able to focus on first consistency. What is the consistency? We have talked about a lot. So consistency, we need to keep the consistency. Your writing should be consistent, and the database should be consistent. What is the consistency? right?
Response.
Response, right? Response. Very close to the next one, next property, availability. So available. Consistency.
Stable.
Stable in terms of data state. So do you remember the database state in the advanced database design? So we focus on actually schema to design the data structure. So employee has the employee ID and so on. And the department has a D number, address, and so on. So this is a schema. Plus, we need to create the data. Insert the instance. So that has the schema and the data. So this is called the database state. Okay. So database is it's kind of an image at certain time. Image at certain time. So as I mentioned here, the data and database system is a live thing along the time. That time is not the same as a human perception. The time, it can be just sequence number or clock and whatever. Anyway, it's going on sequence number. So along the time, so this one database state move to another database state. For example, when I update 1, okay, to 2. So if my query starts here, okay, it should be, even though my query ends after update, we need to guarantee consistent. The output of A is the 1. This is the consistency. So consistency means it's mostly linear consistent. So linearly along the time, it should be the satisfied, the guarantee. So that is the consistency. What is the counter example of the consistency? Non-consistency system. What can be the? Sometimes it's better if you think about the counter example. Yes. Unreliable. 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 I mean the example. Think about the Facebook. When you post a message or the comment or like, can you see your message right away? Sometimes even you cannot see the comment that you write, post. Also, your friend like it or the comment it, so it shows the number of comment is 9. But when you open it, you can see only a couple of them. That may happen a lot. So why? Is it ghost? It's not actually consistent. Because you are accessing the system, database system, Facebook database system in New York. But your friend, the comment on the India server in India. So it's not actually consistent, not synchronized yet. So Facebook system is not synchronized, not consistent. Okay? Is it really a problem? You complain, but eventually you will see the message. So that is non-consistent example of the non-consistent. However, think about the banking system. Your friend transferred the money, $10,000 from India to New York. If that is not available, not consistent, everybody will be crazy. Or stock market system. Because of that, those kind of systems are called online transaction processing, OLTP, the system. So OLTP system need really strong consistency. It's the most important part. Even though not available, it should be constant. Otherwise, the people will not use that system. So I click to buy a new stock, like what is the most hot. What is the stock nowadays? Machine learning or the Amazon? But so you guys heard the news. So it will be new product from the Amazon store. But I click first. Click to buy the new stock. But if the system, the process, the transaction which started later, it's not consistent. Okay? Because of this reason, relational database support really strong consistency. still that is the main reason why relational database system is the most popular the database system. Anyway, so go back to the that is the consistency. So think about the relational database. That's really consistent system. So next one is A. And among the cat, three property. Actually, three property of this distributed system. But C and A, in terms of this centralized server, we can understand C and A. A is availability. Availability means, I think somebody answered.
Where's the response?
Yes, always response. If I want to read the data, yes, get back to this. The function is always working to get this one. Okay, no matter what happens. It doesn't matter whether it's a consistent or not. So availability means it should be the system should be available whenever you request, whenever you run that function. So which one is not available system? Think about, for example, we have the two systems, A in India, another one is in New York. Okay, so in India server, A is equal to 1, then updated. So we try to synchronize. So if your system is available, okay, available, you need to synchronize. While you update this one, you need to update the A in the New York server. You should update. Okay. If that is consistent, really. Okay. But to do that, while you copy, synchronize this one, you need to stop your system. Why? Because if you make them available, this while you are transferring the new data, it's not consistent, right? So it's kind of trade-off sometimes. So C and A, how can we keep the both consistency and availability? Okay, so what kind of requirement?
It deals with fault tolerance.
With a strong network.
Which means single server. Single server. Right? In the single server, it's always available. To keep the available, we can have the high availability. The server, like the backup, standby server even. So that is the reason the single centralized server is both consistent and available. So because of that, it's not easy, even impossible to make the relational database, the distributed system. Later we will talk about the gap because of gap theorem, but it is not easy, even almost impossible to make it. Not almost, it's not possible. So that is the availability. So C, consistent and available. So far, in our computer database system, most of computer system focus on such as C and A in terms of this one. Okay, consistent, the consistency of this function, and availability of this function of that. Okay, then if we are considering such a distributed system, and another property that is the partial tolerance. What if I make my body? I have one body and make partial. Is it tolerable? No, I really die. Okay, it's not partition tolerable. Okay, sometimes some of the students got confused. What is really partition tolerable? If my body is partition tolerable, even though I cut my hand, in the entire body, I can do whatever I want. So that is a partition tolerable. But my body is not partition tolerable. What about this system? This one. Is it the partition tolerable? If we make it the partition, this system will be gone. If something happens, so you cannot keep running. However, what about this one? If you have the distributed system, they probably connected to the network. If this one is something happened, like the network failure or something disaster, but still using the other server, so same the operation is going on. So even though you make the partition, but it's tolerable. So partition tolerable. That's the third, the main character, not main, but the important characteristic of property of distributed system. In a single system, it is not possible partition tolerable because it said it's atomic one node. If we make a partition, it will be gone. Okay. However, if we have such a number of distributed system, even though make a partition, then it's tolerable. So to understand the P, the last one, so you can just imagine it's a distributed system. Okay, not single node system, it's a distributed system. So these three are the characteristics of property of the distributed system. Especially if we do not consider this one, C and A are very important, the property of the single node centralized database system like the relational database. Okay, that long time ago, so probably 2000 something, 80 something, I cannot remember the when. It's 2000, Eric Brewer. So he is, I think, from England. So Eric Brewer. It was a conjecture. Conjecture means, what is the difference between theorem and conjecture?
Theorem is proven.
Proven? It's not proven. So like anyone who knows about the Fermat last theorem? Everybody knows this one. There is a general solution of this. Okay? And the x3, yes? What about the xn? So Fermat proved, the Fermat said, the Fermat is French, Italian, I cannot remember, it's the 17th, 18th century, very famous, the mathematician. He said higher than the 3 degree, so 4, 5, 6, doesn't have a general solution of this one. He said, in his letter, he said, I proved, but I do not write the solution. He said that he proved, but he didn't. So after that, the really many mathematicians, when I was a student in the mathematics department, I learned that. It was called the Fermat last theorem or Fermat the conjecture, because nobody proved. Nobody see the actual solution of the proof of the Fermat's last theorem. Then finally, several years ago, it was proved officially. So right now it is Fermat's theorem, not the conjecture. There are a lot of conjecture. Somebody said that this may be, yeah. For example, the prime number. Then regarding to the number, prime number is a number theory is one of the area, the very interesting area in mathematics. So there are a lot of the idea, well, it's kind of hypothesis, but it's not proved. And really, many mathematicians spend all their life to prove that. If they prove, then they is famous, recognized, but 99.99 that they waste their life. I'm not sure, but really, still many of them. So, Cat theorem was proposed in 2000 by the Eric Brewer in the symposium. It was not proven. He said that it's intuitively everybody know. What he said is among the three property, distributed system can satisfy with only maximum 2 property, either CA or CP or the AP, which means CAP. There's no distributed system that satisfies with all 3 properties. Intuitively, we understand. I will explain that way. Okay. But later, I cannot remember the professor name in the MIT, the mathematical proved that this one. At the time, he or she probably, professor, used the number of node n and how many replica of each data m, and they actually make the equation and mathematically prove later. But intuitively, we are going to understand intuitively, informal way of this one. So, suppose that the system satisfies C and A like this one, okay, relational database. Then this is the assumption C and A. Is it possible to make the P is okay in the distributed system? So it's a consistent and available. Means like the relational database. So whenever you access the data, request the data, whenever you execute this query function, it will return. And also that is the consistent. Is it possible in the distributed system? So if you update the data, it will take anyway time, like the epsilon time, to synchronize this. It is not possible at the real time, really real time, at the same time update A equal to, A equal to, A equal to all of them. No, it's not possible. At least the moment of time you need. Okay? Then, if your query is less than the epsilon this time, then it's not consistent because it is a partition, a distributed. So it is not partition tolerable, which means if you keep the C and A, only C and A, P distributed system is not possible. Similarly, if you keep the A and P, which means available and the partition. So whenever you request a query, it will respond. Response and response and response. So can it be the consistent? It's the same way we can understand. The consistent may not be possible. Why this is to make the synchronized? At that time, system should not be available. If you want to keep the C over here. Similarly, the consistent and the partition. It's a real consistent and it's on the distributed system. So to synchronize, during that time you need to stop. Okay? It's locked. It's locked and stop the service. So which means it's not available. So at most two properties are possible in the distributed system. That is the cap theorem. So you can understand what is a cap theorem. In terms of cap theorem, as I mentioned here, so relational database is the C and A. This is the single node, the server. Then, however, we are interested in what? We have discussed when we have the really big data, single node is not possible. We need to consider distributed system. So distributed system is the P, the partition tolerance, right? So we need to keep this. Means according to the C cap theorem, we cannot get both consistency and availability. Instead, we need to select one of them. Either the consistency. So one approach of the NoSQL database is consistency rather than availability. Or this, availability over consistency. So for example, this one, Facebook, like many of the social media data focus on like this. Okay? The consistency is not that important, so we can keep this one. What about this? The C consistency and the partition, which means at the moment we can stop, which is not available, so we can keep the consistency. Okay, that so somebody said the CA only without that is not the distributed system. It cannot be distributed system. So we need to consider either C and P or A and P in our NoSQL database. So, any questions? If you are interested in the mathematical proof of this, so you can find the paper. And also this is your reading assignment, so please get used to it. So this CAP theorem looks very simple. However, it's a kind of fundamental to understand history of the database system. Even the C and A in the relational old SQL-based database system and NoSQL database. Then I'd like to introduce the new SQL database based on the CAP theorem. Okay.
Wasn't this the first reading assignment?
Oh yeah, first reading assignment. Was it the first reading assignment? Yes. So this is what we discussed so far for a long time, but I'd like to give the side story of the CAP theorem to understand what is the database system and what is the relational old fashioned system based on the CAP the theorem. So I know the first time is not intuitively. It's not easy to understand intuitively what is the C, what is A, what is the P. Think about the counter example or the sample or the example of such availability or consistency or partition tolerance. Especially partition tolerance means think about if you cut the arm or body, can you survive? If you can do all your daily life after cut your arm and anything, it's a partition tolerable. Otherwise, it's not partition tolerable. So single node server cannot be partition tolerable. So only the distributed system can be the partition tolerable. We will see this one later. Okay. So CAP theorem can support only at most two of them. Okay. So then this one was proposed in 2000. It's the University of Berkeley, not England. Somebody don't like this diagram, like this one, because when we talk CAP theorem is from the distributed system. Distributed system should keep the partition tolerable. Okay, so but this still makes sense if you consider the consistency and the availability as a single node system. There is a relational database or a centralized system in between. So, okay. The meaning of that I already. So here, there are actually I explained the very high level the consistency. However, there are different types of the consistency in the system. Okay, strict consistency means like the relational database. Once it is committed, so we will discuss more details in the next week regarding to the relational database. But if you remind the transaction management in the database, relational database. So database, how many different operations do we have in the database? CRUD. Then this one is a read and all the others are write. So actually basically it has two types of operation in our database system. Read and write. Okay? Then our database system, when you query, like the select, insert, delete, update, database query, only one operation, one read, one the write? No. Inside there are a bunch of the read and write operation inside. Right? Even though you insert the data, not only just insert the data, you need to update catalog database and many other information. That should be consistent. How can we keep such a consistency in the relational database? Using transaction. So transaction is set of operation. It's a logical concept, but it should be atomic. Atomic means all or nothing. So one transaction may have a number of read, write, but all this operation will be applied all together or not. Transaction start, transaction end. So because of that, transaction always end with commit. So commit is the command to explicitly the specify that this is the end of a transaction. You must always commit your transaction, but you didn't. It's automatically commit. Okay. Some of the database program is support automatic commit. So at that time you don't have to. That doesn't mean it's not commit. It's always commit. So this is the transaction. So using that the transaction, then also if you remember the serializable, because there are many transactions also. So how many transactions are running at the same time? Many. And inside some, even though you have transaction one here, there's another transaction. So this one has read, write, read, write, read, write. So you need to schedule that. That scheduling called serializable. So that support, that is for the strict consistency. It is the strict consistency. Because of that, online transaction processing use that the relational database so far. Another type of consistency means tunable consistency. Tunable, as the name implies, it can be various. Tunable. For example, when you start the transaction, I read the A. Okay? Then A is changed. Then if you write the A again, so maybe not consistent. So when you read the data A, so it can specify whether I'm going to keep this one as the consistent. Then make the version or version another version, something like that. Or ignore. So even though it's changed, so I can just read updated one, like that. So each transaction specify level of that consistency. So it's not very important, even though it's updated, I'm going to read the updated data, something like that. So you can specify the level of consistency for each operation. That is a tunable, the consistency. More relaxed. It's relaxed than the strict consistency. For example, Cassandra uses such a thing. Eventual consistency means first when I read the data, it's an old one, even though it's updated and commuted. But eventually, so later when I run the same query, it was updated, just like the Facebook, okay, or the other social media data. Basically, it's try to support what? Availability. So availability, data system should be available, but consistency is better if that is consistent, but not right away. Even though Facebook message is not shown on your Facebook, but is it the critical? Are you going to sue the Facebook? No, you do not. But that's a different from your banking account. So that is the eventual consistent. So as you can see, many of the NoSQL database uses such an eventual consistency, relaxed consistency. For that, they sacrifice the consistency. But availability is important. If you cannot log on the Facebook or the Instagram, what happens? You move. Another one, or the yelling, or the right? Swear word will be happening. So that is the consistency. Availability, you can understand that partial tolerance. So we already did a simple proof, so I'm not going to do it again. So you can check your reading assignment again. Also, that can be proved by the mathematics, the formal way. So if you are interested in find the paper, that prove. Okay. Then, actually, CNA is not our concept because it's a relational database. So basically, we will discuss the next class. So for your remind. So, but that's very important. Nowadays, going back to relational database. There is a new SQL. So next class we will talk about more details. So that is based on the, we do not partition, no dispute. If you can see the really distributed relational database, you should be suspicious. Then they will try to hide or to minimize the impact. Actually, the problem is this one. This consistency. This strict consistent, this way, the higher level of consistency means the more expensive operation, more higher complexity. So because of that, they relax the consistency, which means it's easier and less expensive operation, less complex. So that is the consistency, and we will see what is the two-phase commit later and some other. So example is a single sum. So it's mostly used in the relational database. And C and P, which means we give up the available relative, which means during the synchronization, the system will not be available. Then, because of the pessimistic locking. There are two types of locking. One is a pessimistic, which means there is another one, optimistic. The optimistic means which one will be strict locking? Definitely pessimistic. Pessimistic is if you update the data or write the data, you will get the lock. Okay? Then until you end, you do not release that item. Okay? So it's a guarantee. So you pessimistic. So during the synchronization, to keep the consistency along the partition, along the node, your system will be locked. Okay? So that is the pessimistic lock. On the other hand, the optimistic lock is if whenever you need it, okay, you get the lock and update and release the lock. Okay? It's an optimistic lock. So sometimes the optimistic lock causes the problem of what?
Conflict.
That is?
Two people
Yeah.
read this data at the same time, one coming in, one has more data.
What kind of a lock? Deadlock situation. So deadlock. So we learned in the operating system, it may cause the deadlock situation. So in relational database, many of the relational database actually support optimistic lock. Okay, because of that, it may have the deadlock. So you need to have the scheduling. That is a serializable, the scheduling that we discussed in the advanced database design. So if we keep the C and P, it's kind of old-fashioned distributed database system that I mentioned. Okay? So nowadays, many of the NoSQL database give up or relax, not totally give up, relax the flexible, the consistency. So that is the A and P, to keep the A and P. Okay? So like the NoSQL database, like the DNS is also. What is the DNS? Domain name server. So are you going to update all your IP address and domain name by yourself? No, actually not. Eventually, whenever they communicate, it will be updated. Some of the DNS do not know the IP address if you change it, but eventually change it. So that is, but DNS server should be available to access. Okay, if you cannot find your host name, you get another DNS like this. So that is the DNS NoSQL. It's a AP. So somebody. There are professors who don't like this way, but this is one way to understand the CAP theorem regarding to the NoSQL database. So if you see the C and P, okay, not CP, C and A without P, it's a relational database, single load system. It's a conventional system, so you can see over here. But if we give up the C, like a lot of the NoSQL database, most of them, typically the Dynamo in the Amazon and the Cassandra Simple Cost, many of the, some of the database are selected for your research and so on. If there are the system like the HDFS, the header distributed file system HDFS is the, is it the CP? What about the availability? It looks like the available whenever we access the data, right? Then it's not changing, it's consistent, looks like. Then how we can explain the CAP theorem for the HDFS? That's another topic that we are going to discuss. To address, is there any way to overcome the limitation of the CAP theorem? Is it possible to satisfy with all three, the property? Actually, it's not possible because it's a theorem, but we pretend, or we minimize the impact, or work around. So we will discuss about such a how to be. Okay? Right now, so a little bit more. So after I finish, then after break, we will talk about that. So such a NoSQL database, okay? In such a NoSQL database, we can classify into the one of these. Also, we can consider the multi-model. Multi-model means some of the NoSQL database supports document as well as the key value. So first, the key value means the data structure in terms of data structure. It's not from the CAP theorem in terms of data structure. So we can consider data as key and value. Think about the log data, timestamp and a lot of information. And next line, timestamp, a lot of information, IP address and request the index.html file or the a.jpg file, something like that. So it's a key and value. Key can be anything as you learn in your header class, and the value is the other. Then finally, we try to the process such a key value. Document is the not really document like the txt file, like the tag file nowadays. The JSON file format. So let me very briefly introduce about those. Some of the students already use that. So what is the JSON? Java script object notation. It was used for what? Communication in the Java application. But they realized that this one is not only for the Java, it can be used for data structure to keep the data. So keep all these things, show the example, like this. You have seen this one. If you learn the Python programming, it's like the dictionary. Very similar as the dictionary. Each one has the what? Key and value. Key and value. It's the attribute name and the value. So it looks like the database. Data. So we use a lot for such a JSON file or such a structured file for the document database. Okay? Not like the PDF file or some PDF is more like what? It's images. Okay? Even though PDF may have the format, but we are interested in such a tag or structured data. JSON file, this is not only for the Java. Most of program languages provide a parser. So, for example, in the Python, you can open and select the data using such a JSON file parser and keep the data in the dictionary format and so on. So, this is the BNF the explanation of the JSON file. So, please, can use the JSON file format. It's not very difficult. If you ever use if you try the couple of times, it can be easily understand the JSON file format for the data processing, data analyzing. Okay, go back to this one. So we will throughout the semester we will learn each document, and column based is one of the characteristic of the relational database is a very strong, consistent schema. Okay, it has name, ID, address. That's it. You cannot change it. Even though there's another phone number attribute, you cannot until you add a new column. Okay? But column based is relaxed. There's no specific schema. Sometimes it's called a schema list. Schema list, the database like that. And also to handle the social media data, which are based on the relationship represented by the graph based. So then the sum of the deviant, the NoSQL database support multi-model. So probably then nowadays there's another one, object. So why don't we consider, for example, document as the object or the key value as the object? It's not the new one, but based on the object, there's object-based NoSQL database. Some of the students already selected such a database. So think about such a category of the NoSQL database in your research. We are going to discuss the more details for each one in the later. Okay, so after the short break, we will talk about, is there any way to beat or overcome the limitation of cap theorem? So we will talk about that after the 7-minute break. So we will resume 7:20.